Today's demonstration involves the Carbide Cannon. This is a cannon built from PVC pipe. It's got a stand. Actually can go up and down. This is based on the plans that were published in a book called Backyard Ballistics, in which we're going to take now calcium carbide and react it with water and see what happens. Before then, though, let's go over some of the reactions that we're going to see today. The Carbide Cannon obviously uses calcium carbide as one of the materials in the demonstration. And we're going to see two reactions take place today. The first reaction is going to be calcium carbide, which is CaC2, reacting with water. I'm going to write water as HOH instead of the more familiar H2O. I'll talk about why in just a minute. Calcium carbide plus 2 water are going to go and produce acetylene gas, C2H2, and of course calcium hydroxide. We can think of this reaction as being classified in one of two ways. The more common way, the way most people would classify this, is as a metathesis reaction. Metathesis is a word that comes from the Greek. It just means transposing or transposition. Or as some people like to say, exchange of partners, or changing partners. Or now we're taking the H from the water, giving it to the carbon, or the acetylene. We're taking the calcium and giving it to the hydroxide. We're simply swapping partners or exchanging partners, transposing atoms in this case. To make acetylene, a new material, and of course calcium hydroxide, also a new material, by simply switching the atoms from what they're initially combined with to something else. So again, we're taking the H now from the water, we're simply giving it to the acetylene, we're taking the calcium, and we're giving that now to the hydroxide. We make acetylene gas, it's the gas that comes on, and calcium hydroxide. That's the normal way people would look at this reaction. I tend to look at this reaction a little bit differently. I tend to think of this reaction as an acid-base reaction. And that's also why I wrote water the way I did. Water now is going to act as an acid. So water is going to be our acid. It's going to be our proton donor. Phosphate acid, proton donor. So this is our acid. The acetylide of calcium carbide is going to be our base. So the acid is going to combine with the base. The base is the proton acceptor, acid, proton donor. We're going to form the conjugate acid of acetylene, which is acetylene gas. That's now the conjugate acid. And calcium hydroxide is the conjugate base, hydroxide being the conjugate base of water. So the stronger acid is reacting with the stronger base to produce the weaker acid and the weaker base. Again, an acid-base reaction. Either way you want to look at this, if we're still making acetylene gas, and of course that is going to be the second equation, the straightforward combustion of acetylene. We're simply going to take acetylene, which I'm going to redraw now as a acetylene molecule. We'll take 2 of those and combine those with 5 molecules of oxygen. It's going to produce 4 molecules of CO2 and 2 molecules of water. And being an exothermic reaction, heat's given off in this process. Energy is released. That means that energy is also produced as a product, so on the product side. And of course, you're about to see in the course of this demonstration the energy released as acetylene is undergoing combustion. And we'll see that now momentarily. Okay, the reaction is between calcium carbide and water. The first thing we're going to do is put water in our cannon. I've got 2 barrel pipettes Each one holds 15 mils of water. The amount's not critical, you just need enough to make sure that a reaction is going to take place. So we're going to put 30 mils of water in the bottom of our container. In this case, the barrel of the cannon. The next thing we're going to do is open the breech. And we're going to measure out about 1 gram of calcium carbide. Okay. This comes packed in a tin. We'll quickly open up the container. Once we put the calcium carbide in, we're going to wait about, let's say, 12 to 15 seconds. And then we'll ignite the gas that's produced. So once we drop it in, we have about 12 or 15 seconds, and it should go burn. And we can hear it fizzing. Going to quickly stopper this. And now, the grand finale, we're going to see what happens when we ignite this. Woo! And that is the methanol cannon, or not the methanol cannon, it's the acetylene cannon, the carbide cannon. Methanol cannon will reserve for a different day.